Hello, everyone. This is the lecture for section 1.3, rates of change and behaviors of graphs. So in this section, this is going to be the first section that we're going to be covering a mathematical formula using the stuff that we've learned in the previous two sections about functions and functions notation, okay? And what we're going to be doing in this section is defining a couple things: the average rate of change of a function, okay? We're going to determine how to figure out if a function is increasing or decreasing or remaining constant. And we're going to start introducing vocabulary like local and absolute extrema. And what I mean by extrema is maximums and minimums of a function. Okay, so let's go ahead and get started. The first thing I want to define is this thing right here, the average rate of change. The idea behind the average rate of change is this thing right here. It is the change in the output of a function divided by the change of its input. Okay, so how much the y variable changes divided by how much the x variable changes. Okay, this right here is the overall idea behind the average rate of change. Okay, mathematically, to find the formula for it, it's this right here. It's the change in the y divided by the change in the x. And if we want to use our functions notation, it's this right here. Okay, and if you guys remember, right, we usually say y is equal to a function of x, right? So the other way that this is usually written out is this: y2 minus y1 all over x2 minus x1. Okay, this is an entirely valid way of explaining the same exact thing. Okay. Also, I should put this out here too: y1 minus y2 all over x1 minus x2. Both of these are entirely equivalent. And I have to explain this every semester I teach this. Okay. It doesn't matter which one you remember. Okay. All of them are entirely valid. Okay. Just make sure that the one that you remember maintains the 1 and the 2. So if you guys take a look, you see how it's 2 minus 1, 2 minus 1. Okay. Make sure you keep that order. Okay. And then over here, it's 1 minus 2, 1 minus 2. So keep that order. Okay. If you flip them, you'll get something incorrect. Okay. All right. So let's go ahead and do some of these. So let me go ahead and do this first example. Okay. Suppose I wanted to find the average rate of change on the interval -1, 2. And these are x-axis values. Okay. These are values on the x-axis. So I want to find the average rate of change from -1 right here to 2. Okay. So this tells me these two values right here on the x-axis tell me my two x values that I'm going to be looking at right here. So this is -1. It's going to be this point right here. Let me do that nice little orange color. There we go. So it stands out a little bit. Okay. All the way to 2, all the way to this point right here. Okay. So using these 2 points, right, I'm going to first write this out. I need to find f of -1, right, and f of 2. And thankfully, that's what the graph is here for. It's going to give us those y values automatically. So -1, the y value is 4. Okay. And for 2, the y value is 1. Okay. At this point, it's plug and chug. So I want to find the average rate of change. So I'm going to have to do f of x2 minus f of x1 all over x2 minus x1. I should write this out before we move on. Up here, you guys take a look, right? x1, x2. I am giving it I know what my x1 and x2 are, right? Okay, so then that means I'm going to be doing, let's see, this is going to be my f of x2, so it's going to be 1 minus 4 all over 1 minus 4 all over 2 minus a minus 1. And make sure, okay, minus 1. Keep this in mind, okay? Both of these equations have a negative innate in them. Does that make sense? Okay, so if your value itself has a negative, you also have to include that negative. So if you take a look, this negative is from the equation. That negative is because it's a negative 1, okay? Okay, from here, it's plug and chug. We get to keep going. 4 minus 1 is negative 3 all over 2 minus a minus 1. These become positive. This is going to be a positive 3, negative 1. Oh, wrong color. Since that is an answer, I want to keep it in green. There we go. Okay, so from negative 1 to 2, right, the average rate of change was negative 1. So it's been dropping. Okay, we'll get to that in a second once we get to a little farther down in the section. Okay, all right. Next example. Turns out this idea behind an average rate of change is how we calculate speeds. Okay, so let's go ahead and do this example. After picking up a friend who lives 10 hours away, Anna records her distance from home over time. The values are shown in the table below. Find her average rate of speed over the first 6 hours. Okay, so we need, according to this, right? Let me write the formula down. F of x2 minus f of x1 all over x2 minus x1. So we need the first 6 hours, right? Okay, so it turns out we only need 2 of the values in this table. We need this one and this one. Okay, automatically, hopefully you guys see this, right? Actually, let me not do F. Let me do D because that's what we're talking about. We're talking about a distance, right? There we go. So hopefully you guys see D of 6 is going to be 282. D of 0 is 10. So off to the races. D of 6 is going to be 282 minus D of 0, that's going to be 10, all over 6 minus 0. Let me actually make that a more pronounced 6. There we go. 272 all over 6. That's what we have. Yeah? And if you throw this in a calculator, 45.333. Okay? And this is how we do the speeds, right? So if you take a look, the top, those are miles, right? And the bottom, those are hours. So we have miles per hour. So for this, over the first 6 hours of her trip, Anna was doing about 45 1/3 miles an hour. Okay. All right. Now let's get into some real nitty gritty stuff. Okay. This is something that you guys are going to have to get comfortable with. You don't have to be comfortable with it right now, but it is expected that you start learning how to do or working through all of this work using fractions. Okay. So that's what I'm going to be doing in this example in particular. This is going to be to work out your fractions. Okay. Okay. So compute the average change of this function right here. Okay. On the interval 2, 4. Okay. So in this case, we have a function, right? There's going to be a need for us to actually compute stuff out here. All right. Okay, so here we go. The first thing I'm going to do, like I did in the previous sections, right? X1, X2. I'm going to define my X1 and X2. f of x1 is going to be f of 2. So that means f of 2 gets plugged into this thing, right? So this is going to be 2 squared minus 1 half of 4 minus 1 half. This is going to be 3 and 1 half, which is also equal to 7 over 2. All of these values, both of these, are completely valid. I'm going to be using the second one that I wrote down, 7 over 2. And you guys will see why in a second. It's actually easier to do it with the improper fractions. It's easier to work around with fractions if you have the improper fractions to do it with, okay? F of x2, I know what x2 is. It's going to be 4. So f of 4 4 squared minus 1 fourth, that's going to be 16 minus 1 fourth, and that is 15 and 3 quarters, or 63 over 4. Okay, we have our values. Okay, so now I'm going to do my f of x2 minus f of x1 all over x2 minus x1. So according to the values that I have here, right? 60, whoa, write it out as a fraction. 63 over 4 minus 7 over 2 all over 4 minus 2. Let me make that a nicer 3, huh? Okay, so now, this is what's probably scaring people right now. How the heck do I do that? That fraction bit, okay? We're gonna go ahead and separate that away, okay? And we're gonna do that separately. I'm gonna do it right here. 63 over 4 minus 7 over 2, okay? So if you guys remember, we need common denominators, yeah? In this case, my common denominator is going to be 4. So I'm gonna do 4 minus 4. I know what those are supposed to be, right? Okay. If I take a look at this one, the denominator is already 4. I don't have to touch it. So this one's good to go. But this one, the denominator is 2. I need it to be 4. Okay. How do I change it? I multiply both the top and the bottom of this function, or this part, by 2. So times 2 times 2. 2 times 2 is my 4. That's how I got my common denominator. 2 times 7, that is 14. Okay, 63, since we didn't mess with it, we're going to leave it alone. So now I get to do this. My answer is going to be over 4. Okay, 63 minus 14, that is 49 over 4. Okay, all of that was that blue that I figured out. Cool. All right. So now I'm actually going to do this. I'm going to grab my purple. I'm going to go boom. I'm going to continue my calculation right here. So all of this is going to be 49 over 4. It's going to be equal to 49 over 4 divided by, I'm going to put parentheses on that one, over 2. Got it? So now you guys are thinking, how do I do this thing? Right? Okay. 49 over 4 divided by 2 over 1. I can grab any number I want and put it over 1. Okay. Now, you guys are probably saying, well, why do you do that? I'm going to show you guys something. You guys probably remember this from, you'll probably remember from maybe 3rd or 4th grade. Okay. What we have here is a division of fractions, right? So I can rewrite this as 49 over 4 divided by 2 over 1. You guys remember that? Now that I have it written this way, hopefully this is how people remember it from, second, third grade, right? Now that I have it written this way, the way that I take care of this, the way that I do a division by fractions, right, is you flip the second one and change it into a multiplication. Okay, so this is equivalent to 49 over 4 times 1 over 2. So notice that this second one, the second fraction, is the one that I flipped over itself. Got it? And now what you guys hopefully remember is multiplication happens straight across. Okay? 49 times 1 is 49, divided by 4 times 2, that is 8. And if you want to throw this into a calculator, 6.125. And we are done. We are done. We are done. Okay. Awesome. Hopefully you guys see how average rate of change is. The work behind it is really, really not that bad, so long as you follow the steps, right? So assign your x1, x2, compute the f of x1, compute the f of x2, and just throw it all in the formula, okay? All right, there's some quick checks that we'll do in class. Let's move on to increasing and decreasing. Intervals of increase and decrease. Okay, so when you want to determine if something is increasing or decreasing, okay, what you always want to do is look at your function as you're going that way. Always go from negatives to positives, okay? Always go from negatives to positives. Always go from left to right, okay? And what you're looking for is what your function is doing. If it's as you're moving from left to right, if your y values are increasing, have something that's increasing. And if your values are decreasing, they're dropping, right? Okay. So for this one, it's already sort of semi-spelled out for you. Increasing on these, decreasing in this one, right? Okay, so the thing that I want to sort of point out is these 2 points right here. Those seem to be the important points. Actually, let me not do it in blue. Let me do it in that nice orange so it shows up, so it stands out, yeah? There we go. So those 2 points are the important points that sort of, it looks like it's going to be switching from increasing to decreasing, and then from decreasing to increasing, okay? The way that we write out increasing and decreasing is we have to do those intervals again. Remember those intervals from last section? We're going to do it in those intervals, okay? So we need to do, let's do the increasing first, right? And the way that we do the increasing or decreasing, right, is we want to refer to the x values in particular. Got it? We want to refer to the x values in particular. Okay, so increasing, if you guys take a look at the arrow, it says it keeps going down that way, right? It keeps going that way. But if we go from, like I said, from left to right, right? So if we go this way, in this strip, in this piece right here, we are climbing, okay? So we are climbing everywhere from negative infinity to -2, okay? From -2 to about +2, right? We are decreasing. So that one's not counted in this one because we're only strictly talking about increasing, okay? And then at +2, it increases again. So I want to do union to infinity. There we go. So we're saying that between negative infinity up to -2, and then from +2 to infinity, our functions, if we read them from left to right, are climbing. decreasing. Hopefully you guys see the answer for this one. -2 to 2. Boom. Okay. From left to right, from -2 to 2, your y values are dropping. Done. Cool. All right. Okay. This brings up something that we got to discuss now. Local maximums and minimums. Okay. So I want to kind of define what both of these are. Okay. A local maximum occurs whenever a function changes from increasing to decreasing. Okay. And the local minimum happens when the reverse happens. It goes from decreasing to increasing. Okay. Okay. So just to show you guys what I'm talking about, right? I'm going to do an XY graph here. My X and Y. I'm going to do it over here too. Let's draw a straighter line than that, huh? Whoa. I'm telling you, you guys, it's harder to do this on a computer screen. There we go. These are my X values and these are my Y values. So I'm going to grab my blue line, right? I'm going to draw a function. There we go. I'm going to draw something else over here. There we go. Maybe. There we go. Okay. Local maximums are going to be these points. You guys see that one? You guys see that one? If you look at our functions, right, as we read them from left to right, at each one of those points, before the point, right, it was increasing, and then after that point, it's decreasing, right? And same thing for local minimums, right? This point right here, before the point, it is decreasing, and then after that point, it is increasing. That's why we have a local minimum there, okay? So they tend to be real easy to pick out, okay? For this function right here, okay, it looks like an important point is that one right there, and then maybe this one right here, right? Okay. Oh, not what I wanted to do. So increasing, decreasing. So let's do increasing first. So we see that the increasing strip is this piece right here. This is the only strip where it's actually growing, right? And I want to refer to the X values. The X values there are -1 to +1. So my interval here, -1 to 1. It is decreasing everywhere else. So all of this is decreasing and all of this is decreasing, right? So we would want to say -infinity all the way to -1, union 1 to infinity. We are done, at least with increasing, decreasing. And I just noticed I did not give myself enough space. There we go. What a time to be alive, right? There we go. Now to find local extrema, local maximums and local minimums. Thankfully, we already have the points. You guys see that? So it looks like a local max at my point 1, 2. Local min at -1, -2. And in this case, I am going to highlight these points. So my purple dot is going to be my local max right there. And my orange dot is going to be my local min right there. Boom. All done. Okay. let's move on. Let's actually do something that actually that we will more than likely be doing on a regular basis, at least for you guys as well, right? Okay. So for this one, this is a really complicated looking graph. I'll throw it up there in a second. Okay. Most of the time, the easier way to figure these things out, local extrema, increase, decrease, is by just throwing it into a graphing calculator. And that's what we're going to do. Okay. So I'm going to go ahead and do a double screen here. Okay. Bam. And we want this function. So I'm going to throw it in there. F of x is equal to 2 divided by x plus x divided by 3. There we go. There's our funky graph. Let me actually make it nice and visible. There we go. There we go. All right. Okay. So I want to full screen this thing so I can show you guys what's going on. This is our graph. Hopefully you guys see it. It's that the red section that's right there. Okay. If you use Desmos, it'll give you the max and mins. That's why I like it so much. The dots sort of are given to you automatically. You don't have to do anything. It automatically computes it for you. Okay. So what I want to do now is I'm going to grab my snipping tool. I'm going to take a picture of this so we can throw it in our notes. Okay. And let me zoom out really quick. Paste it in here. Bring this down, put it in our notes, zoom back in. I'm getting better at this, I'm telling you. What a time to be alive. Let me center this a little bit more. There we go, there we go. How's that? Bam! Look at that. Oh, and then it does that. Sometimes my computer does this crazy thing where it just wants to scroll on its own. There we go. All right, so we have everything we need. Okay. It already is giving us our 2 points of interest, this one and this one. Okay. Let me not use that orange, let me use the yellow. There we go, that one and that one. All right, so let's do the max and min since it's already there, right? So local max. Okay, this one's going to be a little confusing, but just keep in mind we have already these things defined, right? So a local max is when it's increasing before and decreasing after. Got it? Increasing before and decreasing after. That is this strip right here. So it's increasing before, decreasing after. Okay, so then that means that our maximum is going to be our local maximum is going to be negative 2.449, comma, negative 1.632. And our local minimum, right? Same definition, except backwards, right? A local minimum is when it is decreasing before and increasing after. So this is going to be our minimum, 2.499, sorry, 49, comma, 1.632. Okay, so this is the thing that's going to be a little, this is the thing that probably will feel real confusing, right? This point is higher than this point, right? But this is our local max. This is our local min because of how it's defined. Just keep in mind of the definition, okay? Okay, so we have our local max, local min, right? Now we can do increasing. and decreasing. So increasing, remember, as we go from left to right, we're looking at the y values that are growing, right? So that only leaves these two sections right here, right? From here to here, it is increasing. From here to here, all the way down this way, it is decreasing. From here to here, it is decreasing. Remember, we're going from left to right. And these two pink strips, right? My y values are dropping, right? And then from here on, it is increasing, right? So increasing from negative infinity to negative 2.449 union 2.449 comma infinity. Remember, we are only looking at the x values. The x values, that's what we're referring to, right? And then everything in between, right? Negative 2.449 comma 2.449. These are the pink regions that I have highlighted, right? That is where your function is decreasing. Okay. All right. I think that is it. Well, quick checks. We'll do these in class. Okay. I believe that is it. I believe what comes up next is lecture questions. If you have any questions on these, please come see me at my office hours or we'll work them out in class. Besides that, happy studying.